Okay, so this problem begins by making a statement that's probably not a great surprise to any of you. This says that the amount of postage Y required to mail a letter is a function of the weight X of the letter. So that means that the postage depends on or is determined by the weight of the letter. And so for any of you who have ever mailed a letter, that statement is pretty obvious. However, what we want to do in this problem is take this sentence and we want to rewrite it as a mathematical expression using function notation. If we assume that this function that relates the weight of a letter or the postage that is required to mail a letter to the weight of the letter, if we assume that function is named P. So we just want to translate this sentence into a mathematical expression. Now that expression is going to take the form of an equation, and here's how we'll begin. So we know that we're calling the amount of postage in this example Y. So I'm going to write down Y first. And this sentence says that that amount of postage is, which often translates in a mathematical expression to an equal mark. That is often means is equal to. So Y is equal to, or the amount of postage is a function of the weight of the letter. Well, obviously the weight of the letter is represented by the variable X, but how are we going to incorporate the information that Y is a function of X? That's where the name of the function comes into play in this mathematical expression. So using function notation, what we're going to do here is write that Y is equal to P of X. That's how you read this equation, Y equals P of X. But the way you read it is not the same as the meaning of that equation. What that equation actually means is that this quantity Y is a function of the quantity X. In other words, the amount of postage required to mail a letter is a function of the weight of the letter. So here is how we can take that sentence and write it as a mathematical expression. Y equals P of X, which means Y is a function of X.